The James Webb Space Telescope, JWST, humanity's most advanced window into the cosmos, has brought forth astonishing revelations about Pluto, the once dismissed outlier of our solar system. Long regarded as a barren, icy relic wandering on the fringes of the Kuiper Belt, Pluto is now being redefined as a far more intricate and dynamic world than scientists ever imagined. The telescope's powerful infrared vision has unveiled phenomena ranging from potential hidden oceans beneath its crust to perplexing atmospheric processes and enigmatic chemical patterns scattered across its surface. These findings have not only challenged decades of assumptions about Pluto, but have also ignited deep curiosity and debate among planetary scientists. For decades, Pluto was dismissed as a cold, static rock, unworthy of the same intrigue as the inner planets or the larger outer giants. However, new evidence suggests that beneath its frigid and desolate exterior lies a planet teeming with activity. Signs of geological processes, convective ice movement, and unusual chemical signatures are gradually painting a portrait of Pluto as a complex world capable of surprising resilience. At the center of these discoveries is Sputnik Planitia, an expansive heart-shaped basin of nitrogen ice that has become emblematic of Pluto's transformation in the eyes of science. While this bright plain appears still and frozen from above, it conceals secrets that may alter our understanding of habitability in the solar system. Beneath its glacial shell, researchers believe there exists a vast subterranean ocean, kept liquid by internal heat and shielded by miles of ice. The possibility of such an ocean is monumental, for it hints that even distant and frozen bodies may host environments suitable for life. If this hidden ocean indeed exists, it would be warmed by heat emanating from Pluto's radioactive core, a natural furnace that, despite the planet's remoteness from the Sun, could sustain liquid water for billions of years. This potential ocean makes Pluto a member of a growing class of icy worlds, such as Europa and Enceladus, where conditions for microbial life may quietly persist beneath impenetrable crusts. The idea that Pluto could harbor life, no matter how simple, has turned it from an afterthought into one of the most captivating worlds in the solar system. Even if no organisms currently reside there, the chemistry present within its crust and subsurface offers tantalizing clues about the processes that precede the emergence of life. On the surface, Pluto is equally captivating. Towering mountains of ice, some rivaling the great peaks of Earth, rise dramatically against smooth plains that appear remarkably young in geological terms. These formations suggest recent activity, contradicting earlier beliefs that Pluto was geologically dead. Heat generated deep within its core fuels convection currents, allowing nitrogen ice to behave like a slow-moving, frozen analog of lava. This slow churn reshapes the landscape, creating the striking terrains that astronomers now study in awe. Such discoveries disrupt long-held models of what small icy planets are capable of, forcing researchers to rethink the mechanisms that sustain activity on worlds so distant from the Sun. Pluto's potential as a host for life becomes even more intriguing when considering the chemistry on its surface. Its reddish spots, unusual against the otherwise pale icy terrain, are thought to be caused by tholins, complex organic molecules formed when ultraviolet light from the Sun interacts with methane in Pluto's thin atmosphere. These tholins eventually drift downward, coating the surface in distinctive hues. While they may seem like mere chemical stains, their importance lies in their connection to prebiotic chemistry, the very processes that can lead to the creation of amino acids, nucleotides, and the other building blocks of life. If tholins interact with subsurface water, as some models suggest, they could form a dynamic chemical environment akin to a laboratory for life's earliest reactions. The idea that Pluto may be fostering prebiotic chemistry opens up thrilling new possibilities. It suggests that the birth of life is not restricted to planets orbiting comfortably within the so-called habitable zone of their stars. Instead, life's spark could emerge in the most unlikely of places, within frozen dwarf planets at the edge of the solar system, or perhaps even in exoplanetary systems far more extreme than our own. This expands the boundaries of astrobiology, pushing humanity to reconsider what environments might truly be habitable. Adding to Pluto's allure is its relationship with its largest moon, Charon. Unlike most planet-moon systems, Pluto and Charon are nearly equal in size, locked in a unique gravitational dance that has shaped both bodies profoundly. The gravitational pull between them generates tidal heating, which further contributes to Pluto's internal warmth. Meanwhile, Charon itself displays massive canyons, unusual coloration, and surface patterns that hint at a shared geological and chemical history with its parent world. Some scientists speculate that material may have even been exchanged between the two, carrying with it organic compounds or chemical precursors that could one day be revealed as essential steps toward life. The James Webb Space Telescope's infrared instruments have been vital in piecing together this complex puzzle. By peering into wavelengths invisible to the human eye, Webb has mapped Pluto's surface with unprecedented detail, detecting subtle temperature variations and revealing traces of organic compounds that earlier missions could not identify. Its observations of Pluto's atmosphere have been equally revealing. Though thin, Pluto's atmosphere undergoes dramatic transformations as the dwarf planet moves through its elongated orbit around the Sun. These changes, driven by the waxing and waning of sunlight, allow scientists to study atmospheric dynamics in an environment unlike any other in the solar system. One of the most remarkable aspects of Pluto's environment is the ongoing presence of geological and chemical activity despite its small size and extreme distance. Scientists once assumed that such a distant world would be geologically dead, its heat dissipated long ago. Yet Pluto continues to defy these expectations, maintaining an active interior and reshaping surface features even today. This resilience not only fascinates planetary scientists but also strengthens the argument that similar icy worlds scattered throughout the galaxy may hold untold surprises. The possibility of life beneath Pluto's crust remains speculative, but the implications are staggering. If microbial life exists within its hidden ocean, shielded from space by miles of protective ice, it would demonstrate that life can emerge and endure in environments unimaginably different from Earth's. Even if Pluto contains only the building blocks of biology, amino acids, simple organics, or evolving chemical networks, it would still mark a profound discovery, proving that the seeds of life can exist far from the warmth of a star. As researchers contemplate these possibilities, future missions are being imagined. Proposals for orbiters, robotic landers, and even cryogenic submarines capable of drilling through Pluto's icy crust have begun circulating among the scientific community. Such missions would directly analyze its surface, subsurface, and atmosphere, searching for evidence of tholins, organics, and chemical interactions that might support life. For now, these ideas remain ambitious dreams, but the excitement generated by Webb's discoveries ensures that Pluto will not be neglected in humanity's quest to explore the solar system. The re-examination of Pluto also carries philosophical significance. Once downgraded to a dwarf planet, Pluto is now reclaiming its importance in planetary science. It stands as a reminder that even the smallest and most overlooked bodies can harbor immense complexity. Each new revelation about its geology, chemistry, or atmosphere deepens the mystery and compels humanity to keep exploring. Where once Pluto symbolized the limits of our solar system, it now represents a frontier of possibility. The discoveries made by the James Webb Space Telescope underscore an essential truth about exploration. The universe is far stranger and richer than we imagine. The revelation of Pluto's dynamic geology, hidden ocean, and chemical potential is not merely about understanding